Hello everybody, Adam Lusek here, and today we're going to talk about 5 big trends of applying artificial intelligence to e-commerce. And so coming from a sales and marketing background myself, I've always been interested and I've been hearing a lot about how artificial intelligence is going to revolutionize how e-commerce works. But most of what I've been seeing, honestly, are just kind of articles that give you general overviews of some very broad topics like making e-commerce engagement more productive or, personalizing your product recommendations that usually end in, in the instance of Salesforce here, some sort of conversion into them just selling you a product and how their product can help you out with e-commerce. So what I wanted to do is highlight 5 very specific applications and examples of how modern day AI models, including language models, embedding models, and diffusion-based models, can be directly applied to e-commerce scenarios. So today, we're going to look at virtual try-on via diffusion models for actually trying on clothes with image generation capable models, custom product photos across various scenes, also with diffusion models, and then we'll look at some ways of creating product recommendation algorithms with embedding models. And then for our 2 language model examples, we're going to be looking at the idea of the language model sales copilot, and then also some of the things that I've been seeing around succinct product review summarization. So to start with our first example of virtual try-on via diffusion models, most of what we've kind of seen with virtual try-on in the past is actually what I'm displaying right now, which tends to be augmented reality-based solutions, similar to what, Warby Parker has here, where I can, try on some fancy glasses, or even this can be applied to other stuff, like I've seen Sephora do virtual try-on for makeup, where you can actually test out some of the makeup with their app using augmented reality before buying it. But some of the interesting research that's been going on is actually generating custom photos on the fly. And this usually takes the place of diffusion models that actually can generate images, things like Stable Diffusion or Midjourney, and applying them to scenarios where you can actually look at a product on yourself. And then the hope here is that it can actually give you a much more realistic depiction of how this article of clothing in this example might actually look on you. So for this example here, I'm using a virtual try-on model via concatenation that was released from some research from Sun Yat-sen University, among all of these other different labs. And what they've been able to do is actually take a stable diffusion version 1.5 model, apply some masking and inpainting along with additional training and some different pruning of different steps in between to create a model that can actually take a piece of clothing, take a picture of either you or, some clothing model, create a mask, which is going to be where the actual image is going to be generated within, and create then that final output of your model or reference in that article of clothing, which for this example, I put myself in this Supreme fuzzy jacket thing here as an example. And so they have a Hugging Face space where you can actually try this out. So for our example, I'll just take a quick photo of this first model here and then show a bit of a different generation where I just used the try-on of just a shirt. They also offer the ability to do kind of lower, like your pants or shorts, or an overall style fit. So I'm going to try and apply this style to this model here. So let's submit that and see what it's able to do. And so after about 30 seconds of processing on what I believe they have here to be an A100, this is what we've gotten for our output. So we can see that we've taken our reference model picture. It's drawn a mask of the overall body of him because we clicked on this overall section right here and then transferred over the output from the woman to this man here. We can see that there's a few limitations. Of course, it doesn't get precisely exactly all of the detail from this picture here, from like the shirt or the top here. And then because we only have the top of the jeans, it gets a little bit of the detail there, but then the rest of this is actually just fully made up and generated from the diffusion model. But we can see that it's starting to get pretty good at actually being able to outfit the model here into a new outfit. So you can imagine that in the future, something like this, where it rapidly is able to create a photo of how you look in a very personalized manner in some sort of outfit could definitely revolutionize how different clothing lines or clothing brands, things like maybe, Zara or H&M type of shops, could actually change their e-commerce and online user experience, allowing you to try on clothes and see how you might look in an outfit before needing to actually go into a store or purchase or try something on. And as an interesting final point, I think this could actually be a really good idea. If you have a picture of yourself actually out and about or somewhere and want to see what it might look like if you had a different outfit on, they have been researching, actually trying this out with pretty decent results. So pretty cool, could change the way that we actually are able to try on virtually different products. For a second example, this is also going to follow in the lines of diffusion models. We're going to be looking at different dynamic product photos via diffusion models. And the main idea behind this is instead of actually having to go out and do full product shoots, which can actually be a little bit expensive or costly and time consuming, what you might be able to do is kind of train a diffusion model, something like Stable Diffusion or Flux or one of the big ones like Midjourney, to actually understand what your product is and then be able to generate different scenes around your product. So I have two examples here, but for the first one, I wanted to find a product or something of mine that was completely unique. So I actually used this different little twisty puzzle Rubik's Cube style thing. And the reason that I chose this is because it's the only one in existence because I designed and created this and 3D printed it myself. If you're part of kind of, the community that's interested in different twisty puzzles and Rubik's Cubes, you can think of it as a 5-layer square one that has different levels of bandaging across all of the layers. But to actually apply this idea of generating custom photos for my, quote unquote product, which in this case is this puzzle that I made, what I did is trained an instance of Stable Diffusion 3 Medium using the Dream Booth method. And the Dream Booth method is a diffusion model-based method that comes out of Google research that allows you to train diffusion models to maintain a subject's permanence across different scenes using a limited subset. So I actually only took about 5 different photos across a few different areas of my cube here, and then ran some training on Stable Diffusion 3 Medium. And the subsequent results that I was able to generate were pretty decent, I feel. I'm able to get different scenes around my cube, maintaining the general consistency of the cube itself here too. Some of the limitations here is that you're actually relying solely on the diffusion model's interpreted and learned version of your product. So you're not actually cutting out your product in some sort of manner and then placing it into these different scenes. You're fully generating the product itself and the entire scene around it. So as we can see, there's some general inconsistencies around the actual product itself, which in this case is my cube, across each one of these. However, in comparison to the reference photo here, it actually, I feel, did a decent job at picking up on the attributes and learning about them. The actual training of this was using the Dream Booth method and some low-rank adaptation methods for parameter-efficient fine-tuning using the diffusers package. So I have the script that I used here to actually put this together along with all of the data to do it yourself, and then I'll attach in the description below a video that I made that walks through actually training Stable Diffusion models from start to finish. So if you're interested in doing something like this yourself, you can check that out. But what we can do is actually generate our own custom photo now using the inference API on Hugging Face, which very nicely has loaded Stable Diffusion 3 Medium, as well as this LoRa adapter here. And the way that Dream Booth works is that it attempts to actually train the diffusion model on your set of images with a unique token. So every time I ran some training and updated the internal weights of the diffusion model, it was all in pair with this text line of a photo of T0K cube. And the hope is that this is a unique enough combination of tokens that when we insert this into our prompt to generate further items down the line, it will actually be able to tap more into our training subset and generate this photo. So let's try a photo of T0K cube in a barn. and see what comes back. So after a few seconds, we can see that it's been placed on some floorboards in what appears to be a representation of a barn. So pretty cool that it actually is able to maintain some decently consistent aspects of the cube. Of course, we can see a little bit under here is getting kind of jiggly and messy, but for the most part, it's able to pick up on most of the features. And we can assume that as we're going forward into the future, and this is only Stable Diffusion 3 Medium, not even the latest and greatest diffusion models that are open source out right now, this will improve greatly and vastly. I also have a second example of my kind of original training when I was learning about this, where I trained Stable Diffusion XL Base, one of the prior generations of Stable Diffusion, on this specific green chair so that I could actually put it into different scenes as well. Very similar to what I did here, just a different version of Stable Diffusion. This will all be linked, of course, in the code that's in the description below. But what we can imagine and our main takeaway of being able to create product photos on the fly with diffusion-based models is the ability to sort of almost create super personalized places where a product might be. And this will allow you to kind of not have to rely heavily on photo shoots, which might be expensive, or be able to put together scenarios for a customer per se of your product in the specific scenario that they might be expecting it in. Something pretty cool with some personalization of product photos. So moving forward from diffusion and image generation based models, I now want to look at how embedding models might be applied. And so in my last video that I posted, I did a deep dive in kind of what vector embeddings are and how they work. But essentially the one-liner is being able to embed something and create this mathematical representation of a concept, an idea, or a thing allows you to place them into some sort of vector database that puts these things all kind of similarly together. So things that are similar, which in this example is animals, food, occupations, and weather, are going to be placed similarly together in the vector database in this quote unquote vector space. I go into much more detail into what that actually means in my latest video on vector databases, so I'll of course link that below. But this is the main thing behind retrieval augmented generation systems that allow you to embed sort of documents, and then let's say you ask a question, it'll find the right documents or the right parts of documents that actually are able to answer your question, and it's all based on this similarity search to see how similar your question might be to a part of a document, which is likely going to be used as context for some further generation from like a language model. Or what we can do is embed a query or a question into this embedding space and then see what the nearest or most similar things are to it. The application back to e-commerce then is to try and see if we can do some sort of product-based recommendation with an embedding and vector representation. So what we'll do is take a bunch of products, embed them into one vector space, and then maybe what we can do then is see whether it's able to pull similar products based on either natural language queries that might be from like a user searching or from similar products themselves. So to simulate this, I have a CSV of 50 made up home appliance products, ranging from, the Steam Press Pro, which can steam iron with ceramic sole plates and vertical steam functions, to the Dehydrator Max, which is a food dehydrator with 6 trays and digital controls. This is all just generated from our friend Claude, but what I did then is put this all into a vector database. So what this will allow us to do is then run different queries that might be either a user question or a different product, and then find similar entries in the database to that product or question. So for our example, we're going to do 2 searches. We're going to do one that just says, I want a coffee maker, and then see what products that are embedded in this vector space actually come up as most similar to that query, I want a coffee maker. And then the second one is going to be more of a recommendation based on an existing product, which is going to be the Fry Air Max. So I'm just going to search over the database with Fry Air Max and see what it returns. So running this real quick, it will, after a second, respond back with the most similar entries in our database to our query. So for this general search of I want a coffee maker, we can see that it brought back 3 products here, which I just asked it to bring back 3, so that's why it's only 3 with this. but we can see that the product is the Brewmaster Elite, which is a programmable coffee maker, the Espresso Plus machine, which is a 15-bar pump espresso, and the Coffee Grind Burr, which is a Burr coffee grinder with 18 grind settings. So for this first example here, we can see that this might be a way to actually convert a user's questions or some sort of natural language, non-specific filtered response into direct product recommendations. And so coming down to our second example here, I put in the name of an existing product, the Fry Air Max, to see what products it might recommend that are similar. Of course, we expect it to bring back the Fry Air Max itself as the most similar to the Fry Air Max, but if we just do a little bit of mental filtering of that out, we can see that the next two products that it recommends is the Popcorn Air Cinema, which is a hot air popcorn maker, and the Toast Oven Combo, which is a toaster oven with convection and air fry functions. So I am not 100% sure that the Popcorn Air is more similar than the toast oven here to an air fryer, but this is also the limitation of only having a database of 50 examples. But with that being said, you can see how using an embedding model with a vector database can create a quick and easy recommendation algorithm that can convert natural language queries or product descriptions into product recommendations. Of course, embedding models can also be trained. So you might think of down the line actually training a custom embedding model to create better and better recommendations based on whatever products you're actually offering. For this general example though, this works out pretty well. For our fourth example, I wanted to talk about that specific idea of the shopping copilot, or essentially the next generation of chatbots, which Salesforce here has said you need to upgrade your chatbots to AI-powered copilots. And essentially what they're saying here is that we want to be able to kind of process natural language queries, things like customer questions about products, and be able to respond in very personalized and meaningful ways to further encourage potential customers down the sales cycle. So for their little example here, they had someone asking, what coffee should I use in my new coffee maker? And then it's able to interpret that and then recommend which product of yours to actually buy. And the cool part about this is that you can combine these with, retrieval augmented generation techniques to actually be able to pull relevant information about a product to be able to converse with someone conversationally using a language model. So the potential customer can actually ask any and all questions about something, and you've got a ready to go, hyper-personalized expert on your product able to answer and generate quick responses and lead them down that cycle. So for my shopping copilot example here, I actually chose the product of the Nikon ZFC mirrorless camera. And the reason I chose it is because cameras have a lot going on. They're very, very subjective based on what you actually want to use them for, and they have an incredible amount of different information and fine details to them. So much so that the ZFC reference guide is actually a 638-page long PDF. So what I thought was this would be the perfect example because I can use some fancy RAG techniques to actually be able to pull from this 600-page PDF the relevant context for a language model to respond to any sort of potential customer questions. So that's exactly what I've done here with what will be a Gradio interface that I'll demonstrate in a second, but essentially it's going to look at your user query, and then if it needs additional information about the camera, it will query our vector database where I've chunked and embedded the entire reference guide here into to pull the relevant pieces as context to respond to your question. And so then, of course, guiding the actual language model to be a helpful sales assistant is very, very reliant on your prompting. So I put together this system prompt that looks a little bit like this. It says you're an AI sales assistant specializing in the Nikon ZFC mirrorless camera. Your primary goal is to guide potential customers through their buying journey, providing accurate information, addressing concerns, and helping them make an informed decision. Always maintain a friendly, professional, and helpful demeanor. Key responsibilities include provide information about the camera, assist customers in understanding how it compares to other Nikon models or competitors, offer personalized recommendations based on the customer's needs, preferences, and skill levels, answer questions about compatibility with lenses, accessories, explain technical concepts in simple terms for beginners while also being able to engage with more experienced photographers, guide customers through the purchasing process, and provide after-sales support information, such as different details and customer service contacts. Interaction guidelines include use a conversational tone while maintaining professionalism, anticipate common questions and concerns, and avoid pushy sales tactics. Instead, focus on educating and guiding, and then a few different potential customer personas to be on the lookout for. And so putting this flow all together gives us a chat interface that looks a little bit like this. So I can say something like, hello, and it won't pull any relevant information, but it'll respond to me pretty quickly. Hey there, welcome to our Nikon store. How can I assist you today? Are you interested in learning more about the Nikon ZFC mirrorless camera? And then what I'm able to do is actually ask any question, and it'll pull all of the relevant details to answer it. So for example, let's just start with something easy, like what makes the Nikon ZFC mirrorless? And let's see what it comes back with. So it's likely going to be pulling kind of any relevant context from the guide and then generating its response based on that. So we can see that it has a little bit of just fun jargon about it, but it also gives us some of the very specific technical aspects, like the different sensors and the mounting systems, advanced autofocus and stuff like that, and a couple of the unique selling points of where this might be. And then in its very nice and conversational manner, asks if we have any specific needs or preferences. So I could say, how good is this for street photography, maybe? And see what it's able to come back with. Which after a few seconds, it's able to answer that it's compact and lightweight, has a cool retro design, and then the high quality imaging will often capture the varied and contrasting scenes in street photography. It has a 209-point hybrid autofocus system with eye detection to capture, quick fleeting moments, and a variable angle touchscreen. So it's able to convert my very loose question, which a general, classic chatbot wouldn't necessarily be able to do, pull the relevant information, and then guide me down this journey of actually learning about this camera itself. I'm really not into photography all too much myself, but it's cool to see that now I've got this expert sales assistant on the Nikon ZFC that's able to tell me all about these and then even give me, example scenarios like candid portraits or dynamic street scenes or creative angles and how this product, the Nikon ZFC, can actually play into that. So you can see that I've also just printed out that for my initial query, which was just, I believe, hello, it didn't invoke any RAG step. But then the next couple questions that I asked, it invoked the RAG step to pull the relevant context from this reference guide and actually answer my questions with some grounding and some actual facts about the product itself. So you can start to see the real power of a language model-based sales copilot that can guide your customers through their educational journey of learning about a product all the way down through to buying it. And for our fifth and final example, and our second language model-based example, one of the cool things that I actually saw recently is I was buying a 3D printer for a little video that's coming up, bit of a sneak peek, and I scrolled down to check out the reviews of it. And what I saw here on Amazon is this customers say section right here, where what it's essentially done is summarized all of the different sentiments and things that people are talking about in the reviews and claims that it's AI generated from the text of customer reviews. It then gives me some examples of actually where each of these different values for the 3D printer come from, and I can actually click in and read more. And I thought that this was a pretty cool and neat feature because getting reliable information quickly to a user is super key with e-commerce, where you want users to kind of make very quick decisions and feel that their decision is thought through reliably. And so one of the biggest and most important things that you can use are actually then reviews and testimonials from other prior customers. Naturally, you don't buy something without looking at the general sentiment of what other people say about it. And so this gives a sort of super quick and easy way to get a general overview super fast to a user to understand the general sentiment and ideas behind a product. So to show an example and simulate this, I've put together my own prompt on actually doing this, along with a few, also generated by our friend Claude, reviews. 20 to be specific, about a coffee maker called the Smart Brew 5000. So I've got 20 different reviews. A few of the examples here of what was generated is that the Smart Brew 5000 is a game changer for my morning routine. Love being able to schedule my coffee from my phone the night before. Mixed feelings about the Smart Brew 5000. On one hand, the coffee quality is excellent. I like the smart features. On the other hand, it's quite loud when grinding beans and the water reserve is a pain to fill. So all of these reviews have some sort of positive or super positive or negative and super negative or in the middle line. And what we're going to try and do is prompt a language model to actually take all of these reviews and then give us that holistic summarization. So I've set up a prompt template here that goes a little bit like this. You're an AI assistant specialized in analyzing and summarizing product reviews. Your task is to synthesize multiple customer reviews into a concise summary that highlights key points about the product. Follow these guidelines. Start with a brief customers say section that summarizes the overall sentiment and main points. Identify 3 to 5 positive aspects. Identify 2 to 3 negative aspects. Note any mixed opinions or areas where customer feedback varies. Create a list of key features or aspects of the product, categorizing them as follows. And then I added in a little bit of an emoji thing here. Present the information in a short paragraph, no more than 5 sentences long. Use clear, concise language, and your output should be structured, easy to read at a glance, and provide a balanced view of customer opinions about the product. And then I provided a few examples from Amazon actually themselves of a 3D printer, an AirTag case, and a bookshelf. And then I'm using LangChain to put together this prompt into a chain so that I can insert in the name of a product and then also all of the reviews that we have in our reviews here. So let's see what it's actually able to generate for us. And after a few seconds, we can say that it says, customers say the Smart Brew 5000 is a high quality coffee maker with advanced smart features, making it a great choice for tech savvy coffee lovers. Customers appreciate the excellent coffee quality, customization options, and smart home integration. However, some users report issues with the app, grinder, and overall complexity, which can be frustrating. I think this is a phenomenal overall one-liner. It then outlines the positive aspects, coffee quality, customizable strength, built-in grinder, thermal carafe, and the negative aspects, app connectivity, grinder jamming, a little bit of complexity and a steep learning curve, as well as some of the mixed opinions, size and counter space, customer service experience, and then it gives me all of these key features along with the identifier emoji for the positives, the negatives, and then some of the mixed emotions here. Well, it wasn't exactly in the super succinct format here. We can see that it was able to provide a very holistic and good overview of all of our reviews, which, would help me make the decision about the Smart Brew 5000. So with that being said, we've just gone over 5 direct applications of language models, diffusion models, and embedding models, 2 different e-commerce scenarios, highlighting some of the interesting trends that I'm starting to see pop up here and there from some of the major vendors actually talking about how AI is going to change the world of e-commerce. I'll have additional resources down in the description below, along with all of the code used in this video, if you're interested in seeing some of these and setting some of this stuff up yourself. But all that being said, if you enjoyed the video, consider subscribing, drop a like, and if you have any questions, please feel free to leave them in the comments. Thank you, and have a great day.